Welcome to the lecture. I'll be talking about measuring and manipulating variables with an emphasis on how your decisions impact validity. A couple of important questions we'll talk about first. One, why do we care about the measurement and manipulation of variables? And two, what is it that we're measuring and manipulating? Well, the first one, we care because your choices in terms of how you choose to measure your variables or manipulate your independent variables have an impact on the internal validity and external validity of the ultimate findings of your study. If you're going to say, oh, this variable had an effect on this variable, well, to be confident that that's true, which is what internal validity is, you have to be confident that you, in fact, did manipulate the variable you said you manipulated, and did, in fact, measure the variable you said you manipulated. And the same thing goes for external validity. When you want to extend a finding beyond your study, well, did you get it right in the first place? Because were you talking about what you say you were talking about? Right? Second, what is it that we're measuring and manipulating? Well, we're attempting to measure and manipulate. Most typically, we're trying to measure and manipulate constructs. Sometimes not. In some basic science, you might be measuring, time just as an indicator of time. But more often, it's you're measuring things that are indicators of something else. Even if you're measuring time, so let's say you're showing people pictures of different faces, and then after a face is a word, and you're having them rate whether that word, how aggressive that word is, right? And you're measuring how long it takes them to make a decision, right? So that kind of lag time between, okay, they saw the word, how long did it take them to say, oh, that word's aggressive, no, it's not aggressive, right? If we're doing that, and what we're manipulating is the apparent racial or ethnic identity of the face that precedes the word, well, our measure of lag time is really trying to be some measure of racism, right? So do you have to think, are you activating these, showing people of different ethnic or racial identities, does that activate different schema associated with violence for you? Right? So yeah, we're measuring time, but we're not saying, well, how long did it take? That's really interesting. We want to know how long did that take, because we think that's an indication of kind of this racial cognition that's going on. Right? So in social science, typically the things we're interested in are not measurable. They're constructs, they're ideas, they're schema. And so they're things we can't measure and manipulate directly, so we have to come up with these operational definitions of our constructs to then measure and manipulate. And the degree that we do that well will, going back a step, have an impact on the validity of our findings. Okay, so in terms of measuring variables, what choices that we make and what kind of circumstances will ultimately influence the conclusions we draw and the validity of those conclusions. Well, a couple things. The reliability of the measures we use, or the methods we use to measure a construct. The validity of an assessment approach, of a measurement approach. Issues related to the sensitivity of the measure, and very closely related to that, the variability of the data that you're gathering, and also the scale of measure that we're using to measure a construct. And we'll talk about each of these in more detail coming up. Starting with reliability. So for classic test theory, excuse me, the reliability of an instrument is equal to this kind of proportion, right? Where you imagine that when you're asking somebody a question, there's some score for their answer to that question that is the true score, right? The absolute right answer for them in terms of estimating some level of a construct. So if it's some question about how depressed are you, there's some number that perfectly represents exactly how depressed they are. Right? And so how reliable your measure is, according to classic test theory, is this portion of, okay, their true score divided by true score plus error score, with the assumption being that whenever a person is answering, they're probably not going to put exactly their true score. There's going to be some error as part of that measurement, and we'll talk about why that happens, what types of error there are, excuse me, in a minute. But again, the closer you can come when measuring something to the true, getting more true score and less error. So if there's zero error, true score over true score proportion is 1, or 100%. You have 100% reliability. As that error score increases, the more error that's included in your measurement, the more obfuscated, the more clouded the true score is, and the lower that percentage becomes, the poorer your reliability. Okay. So what about that error? Well, a couple different types of error that we typically see. They are bias and random error. Now, bias, as opposed to random error, is systematic error, right? Where some people or some participants, maybe they're not people, are measured differently than others, and not because they're really different. They're really truly different on that measure, but just that your measure is acting differently with them than with other people, right? And so maybe there's some variable that correlates with the error. And most commonly, we worry about the error in measurement being systematically different across levels of an independent variable, right? When that happens, we've got a systematic difference across levels of the IV. That's an error. That's a confound, right? But bias can also exist when measuring the error correlates with some participant characteristic, right? So maybe women who demonstrated the same behaviors as men in some observations, the exact same thing, but they're given higher scores on some measure of aggression. Okay, so if that's happening, you've got some bias, and it's systematic, where one group is being measured differently for having the same thing being exhibited, right? The same level of construct. Two people having the same level of depression, one gets a higher or lower score for some other reason. Then random error is non-systematic error. Instead of just some individuals being measured differently than others, it's where there's a recognition that, to some extent, all individuals aren't going to be measured with 100% accuracy. And these errors aren't correlated with any participant characteristic, and they aren't systematic across levels of an IV. And random error typically won't make us think we had an effect when there wasn't, but it may hide an effect, right? Too much noise, too much static to detect the signal that's there can happen with too much random error, which would lead you to make a type 2 error, right? So where does this error come from? Three typical candidates: either from the participant, they bring an error themselves; from the experimenter, in terms of what you do or the way you're designing, you're collecting the data; and then the measure or instrument itself. We'll talk about these three in a minute, but before we do, just want to touch on one other thing here. And that's that fortunately, even when we can't eliminate error, what we can do is estimate how much error is in our measurement. Right? There are statistical procedures developed that help us estimate the degree to which error may be distorting true scores. And most commonly, this involves calculating reliability coefficients based on things like test-retest reliability, inter-rater reliability, and internal consistency. So test-retest reliability is when, so you first develop a measure and you want to show that it's got good reliability. You're not going to use it in a study yet, but you give it to some people and you measure their level of depression, and you give them that same measure a few days later, and people, each person should score somewhat similarly on your measure from time 1 to time 2, right? If you're measuring things reliably and assuming their depression hasn't changed, they should get similar scores. If so, you've got good test-retest reliability. And the more similar scores are across time, the higher that coefficient will be, closer to, usually it goes from 0 to 1. Inter-rater reliability is most often used when you have people either observing behaviors or reading written reports and then making some judgment about level of a construct. Okay, we watch these kids on the playground, and on a scale of 1 to 5, how aggressive were they? Right? And so you look at, when two people looked at the same kid doing the same thing, to what extent did they rate that kid the same? And if consistently different raters rate the same thing similarly, you've got high inter-rater reliability. As you get more drift, where no, I thought it was a 5, I thought it was a 4, oh, I thought it was a 3. When that happens, you have more disagreement, you'll have obviously lower inter-rater reliability. And then the last one, internal consistency, applies to a scale or measure where you have multiple questions. Right? So maybe you have 5 questions, all of them about depression. Because again, if you're trying to measure depression, you're going to get a better measure of it asking 5 questions than asking 1. Right? The more, there's some diminishing returns eventually, but more is usually better when measuring, more data points. So when you have these 5 questions about depression, measures of internal consistency, which are things like an alpha coefficient or item total correlations, excuse me, look at, okay, when people said they were depressed on question 1, when you go on to question 2, did that same person say they were very depressed in 3 and 4 and 5, right? Or, and if so, you've got high internal consistency. But if you have somebody that says, oh yeah, I'm really depressed on question 1, question 2, no, not so much. Okay, well, those 2 questions may not be measuring the same thing then. Your measure, your scale, may not be internally consistent. You might be measuring 2 different things or more. But again, these things can help us get some estimate of how much error is present. And typically we set limits on how much error we're willing to have in a measurement to use it. And how much error is okay depends on which particular coefficient you're talking about and what field you're studying in. So you really have to kind of read the articles in the field you're studying and say, okay, what are people saying they used to justify that their measure has adequate psychometric properties, which reliability and validity of a measure are the psychometric properties. But typically, we're looking at coefficients that are 0.9 and above. Sometimes you see things as low as 0.7, but typically they're higher than. You won't see anything lower than 0.7 being reported as, oh yes, this has good reliability. It's at least 0.7 is kind of the lowest you'll see for any type of measure of reliability. Okay. Okay, so for coming back to the sources of error, the first of the 3 we'll talk about would be the participant, him or herself. And so with participants, a couple things you have to worry about, one of which is demand characteristics. So demand characteristics are basically hints that participants pick up on, either in the materials or from the experimenters, about what responses are expected of them. Now, these hints don't need to be read accurately to have an effect on their score, right? So they might be wrong about what they think is expected of them. It doesn't matter. As long as there's something in that question where they think, oh, this is what they want, okay, now they're not giving you their true answer. You're getting less total true score. You're getting more error score there. Right? So to deal with this, typically what you do is you try to, if you can, measure things unobtrusively. Right? If you're really worried about demand characteristics, then you measure people without them knowing you're measuring them, which there's some ethical concerns about that, right? Because we're supposed to have informed consent to gather data from people. The exception being if no identifying information is gathered, then you don't necessarily need informed consent. If you're not going to do anything to them, all you're doing is observing, and they're in a public place, then you don't need their consent. Right? Like if you wanted to do a study of patterns of commenting on discussion boards, on the internet, you don't have to go track down every troll and get them to sign a form. That data is out there and it's public knowledge. And when you're gathering it, nobody knows you're gathering it, so you could gather that unobtrusively. Right? But again, there's a limited amount of data that can be easily measured unobtrusively, right? Especially for a lot of the things we're most interested in. So another choice you might make is try to disguise your measure somehow, or disguise the hypothesis of your study. So maybe you'll throw in some other questions or other measures frankly, to mislead the participants, to make them think, oh, this study's about this, oh, and I have these other questions about this too, okay, blah, blah, blah. But really, the things they think are fluff are your main questions. The things they think it's about is the fluff. Again, some ethical questions about that. When we lie to participants, that's somewhat unethical, right? And as researchers, you're obliged to debrief them afterwards, where you tell them, okay, sorry, we lied to you. Here's why we lied to you. Here's really what the study was about. Please don't tell your friends in case they take the study, right? Which is like, okay, well, everything's fine. We tell the truth eventually, but there is still this kind of problem where, especially in the 60s, 70s, 80s, in the behavioral sciences, a lot of good research was done with a lot of lying to people and misleading them, and it got to the point where the public developed kind of this distrust of behavioral scientists. And so now people will come to your study kind of looking for, okay, are they trying to trick me? And if they're with another participant, oh, they're probably a Confederate, and they're not really a participant, right? So they've gotten more savvy, and unfortunately, even if you're not trying to trick them, they may think you are, which can affect their answers. So we try to use as little deception as possible, unless you really need to. Excuse me. Another thing that participants can bring with them in terms of bias as a source of error would be social desirability bias, right? And this is when participants distort their responses in an effort to look good, right? So when they're denying racist or homophobic attitudes, oh no, I love everybody, because they're afraid that somebody's going to see what they put, and there's kind of this socially desirable response. And studies have shown that social desirability is less when we assure people of anonymity, but it's not nothing. There's still some social desirability present. People can't shake that idea that, well, somebody might see this, right? So what do? Well, a couple things. One, you can avoid loaded questions or language where there's clearly a right answer. So if you're wanting to ask somebody about a kind of a sensitive topic, be careful in how you word it and the options you give. That will provide people options where you can get some variability in your measure on both sides of the issue, without them having to endorse kind of attitudes like, oh yeah, I really hate this group, they're the worst ever, because you're probably not going to get that. So think about that when wording questions on a survey or designing some other measure. The other thing you can do, other than trying to eliminate social desirability, is if you're worried that it's going to be present, you can measure it. There are several scales out there that are designed to measure social desirability. Right? Where they ask questions like, "Oh, do you read the newspaper every day?" and all this stuff. Stuff that people think, "Oh yeah, I should do that." And so, if that group of people is going to be prone to a social desirability bias, they'll say, "Yeah, I do that, I do that, I do that." Right? And that's not your main measure. You give some other measure, but if you have a lot of people scoring high on that measure, then you say, "Oh well, my other measure may also be impacted by social desirability." But if nobody on that measure of social desirability is real high, everybody's pretty low, you say, well, no, in this sample, social desirability didn't seem to be a big factor. So on my other measure of anxiety and depression, I don't think social desirability contributed to their responses to any kind of large extent. Third thing participants can bring with them, inconstancy and mistakes. Right, so people are inconstant, right? They're not static. They're very dynamic. And you give me a survey question today, and I might answer, a 3 on it. Question on a scale of 1 to 5. Well, how do you feel? Oh, a 3. Tomorrow you come back, and give me that same exact question. Oh, no, I'm a 4. Right? Come back next day, I'm a 3, 3 again, then a 4. Probably my answer would vary across situations around some number between 3 and 4. Maybe, maybe my true score is 3.5. The point is there's some randomness associated with measuring dynamic entities like human behavior, attitudes, thoughts, emotions, right? In addition to that kind of just randomness because we're random people, some people might intend to respond, oh, very true to something, but accidentally mark not at all true, right? They just get confused and mismark something. So there's some error in your measurement just from, quite simply, a data entry error on the participant's part. The best way to deal with this, unfortunately, is to try to get a large sample of behavior, right? And this goes to both number of people, right? Because you're going to have some people screwing up. If you get a large enough group, there should be enough, hopefully enough true data in there that it won't be distorted by some errors. Where if you have a very small sample, just a couple of people making errors can throw everything off. And beyond sample people, talk about sample behavior. Going back to, like I said, if you're measuring depression and you answer that, you ask one question about depression. Well, if there's some error associated with that one question, your whole measure of depression is flawed. Whereas if you have 5 questions, well, if one of the questions was kind of wonky and had a bunch of error in it, you can potentially throw that one question out, keep the other 4, and still have a good measure of depression, right? So typically, when you're interested in something, some construct, you're going to ask multiple questions about it or measure it in multiple ways. And this could include multiple reporters. So having the person report on it, having their significant other report on it, having their parent report on it, observing it yourself, getting written self-report, getting a physiological measurement, all these different things. The more behavior you can get up to a point, the more accurate picture you're going to get of the construct you're trying to measure, because you'll be able to sift out the error, because they shouldn't have the same error in every modality. Right? The other sources of error we'll talk about, the experimenters and the measure. So the experimenters, the people who administer and score the measure in this instance, might be prone to expectancy effects, right? Where experimenters may intentionally or even unintentionally skew the results by treating participants differently based on what condition, what level of the independent variable they're in, or scoring their responses differently, right? And this especially happens whenever there's large amounts of subjectivity in whatever you're measuring. So if it's observation, you're observing couples, and okay, you're observing a couple that's in your therapy condition and a couple that's not in the therapy condition. You're watching the couple in the therapy condition, and one of them kind of smiles, but it could be they just had a little gas. Like, oh no, they're smiling, yeah. So yeah, they're very happy. And the couple in the other condition that didn't have the therapy, they kind of smile, and you go, oh yeah, it's probably just gas. They're not happy, right? Because you expect to see one thing or the other that might tend to introduce some bias in terms of interpreting behaviors. And just real quick, a little aside, interesting story. This has been documented empirically, a really interesting way, where some researchers got a bunch of genetically identical mice, sibling mice, and sent them to different labs to say, oh yeah, we need you to take these mice and teach them to run a maze. We're looking at this theory of learning, yada yada. So not really what they're interested in. They said, oh yeah, these are some really smart mice. They sent to this one lab. To other labs, they said, these mice, they're kind of dumb. So do what you can with them. What happens? Well, the smart mice learn the maze very quickly. The dumb mice take much longer to learn the maze. They're genetically identical mice. They weren't smart. They weren't dumb. They just said, oh, these are smart, these are dumb, randomly. But there was an expectancy effect that impacted how they interacted with those mice and how they measured their behavior. Excuse me. And just like participants, experimenters can make mistakes, right? When giving a measure or when scoring it. Just simple computational or data entry errors contribute to error in measurement. So in terms of dealing with error from the experimenter side, one approach would be standardization of measurement. And that's where you're trying to create a standardized set of procedures for measurement and scoring, where everybody experiences the same thing in the same order. Right? And standardized scoring is especially important if you're collecting observational data, right? Because we want to try to limit the impact of the subjectivity and bias. And if you have maybe multiple raters rating stuff, you're going to do lots of training on your standardization, so everybody knows this is exactly what a 4 looks like on the scale. This is what a 5 looks like. This is what a 3 looks like. Here's the difference between a 3 and a 4 and a 5, right? Here's an example of kind of a borderline behavior. Which one is a 4? Which one is a 5? And you go through all this stuff so everybody knows exactly how to use the instrument that you're using. And the more you do that, the more reliable your measure will be. Another approach to kind of deal with especially those expectancy effects would be blinding or masking. Right? This is where you have the people who interact with the participants and or who score their responses not know what condition the participants are in. Right? This way, they can't expect them to do well or do poorly because they don't know if they're in the control group or if they're in the experimental group. And they might not even know what the study is about. So you may just recruit some grad students to code this data, and they don't even know anything about your hypothesis at all. Then there's really difficult for there to be expectancy effects coming in. And if the experimenters don't know what condition they're in, and the participants don't know, so if nobody knows what condition they're in, neither the experimenters nor the participants, you're talking about a double blind. Right? If just one group doesn't know, it's a single blind. So participants can be a source of error, experimenters can be a source of error, and the measure itself can be a source of error. You might have vague instructions, right? So some participant errors really may be not due to the participants misunderstanding things, but due to poorly worded instructions regarding how to complete the measure. So you want to be sure that you're very explicit and complete when directing people how to enter the data that you're looking for, so that you're going to get the data you're looking for. The kind of classic example, if you put you want to know about participants' biological sex in the demographics section, you put sex colon and a space. Some participants will put yes please or yesterday, and some of them are just being jerks. Some may have misunderstood, but if you want to limit that, be very explicit. So biological sex colon male, female, transgender, other, right? Intersex, whatever options you want to put. So, but make it very clear. Similar to that, you may have problems with just poor design. It may not be clear how to indicate your answers, and this usually has to do with just formatting issues. If people don't know, am I supposed to circle which letter corresponds to what I'm doing, write it in, or should I put a dot between the two answers that I think I'm most like? So again, if you ever have to design your own survey, assume that people are cattle and need to be directed and will be hopelessly lost if you don't tell them exactly where to go, when to go there, and what to do when they get there. But again, designing measures is tough, so as much as you can, I would recommend finding existing measures that have known psychometric properties, that are known to be reliable and valid. Okay, so kind of the first part of talking about measurement, we talked about reliability. Now the second part of measuring variables, we'll talk about validity. And when we talk about validity in terms of measurement or in terms of variables, we're talking about construct validity. Right? Because again, we're interested in these constructs, these schemas, and we want to know, okay, to what degree are the data that we've measured an accurate estimate of the construct we're trying to estimate. Okay. Excuse me. So, what's the relationship between validity and reliability? You can't have validity without reliability. You could have a measure that's reliable but not valid, but you can't have a measure that's valid if it's not reliable. So you could have a scale that you get on that scale, and every day it tells you that you weigh 100 pounds. And let's say, for sake of argument, that you don't weigh 100 pounds, you weigh 180 pounds. Well, then that scale wasn't a very valid measure of your weight. But if every day it told you 100, well, that's very reliable. It never gave you a different answer, right? Another way to think about it would be shooting arrows at a target, right? Robin Hood. If you're consistently grouping arrows in the same place, that's reliability. But they could be consistently grouped out in the outer ring. So you're always shooting high and to the left, high and to the left, high and to the left. Very reliable shooter. But it's not valid. You didn't hit the bullseye, because the bullseye represents the heart of what the construct is. And so if you hit the bullseye once, it's like, oh, do you have validity? Maybe, but if you're shooting 5 times, you hit the bullseye once, and then the outer ring the other 4 times, no, it's not validity. You may have gotten lucky once, so we don't know overall if you're really a good shooter or not. But if you cluster, you got 5 arrows all in the bullseye, well, yeah, now we've got a kind of this valid measure of your shooting ability. You're a good shooter, right? Because you have the reliability and the validity. So to have validity, you must have reliability. But for reliability, you don't necessarily need validity. So some measurement validity issues related to more directly to internal validity in terms of they have a kind of a clear impact on our ability to draw conclusions about cause-effect relationships. And we'll talk in a minute about other aspects which are more relevant about the degree to which our findings can be generalized outside the study setting, external validity. But for now, focusing on kind of things related to internal validity, look at the content validity of a measure, which all of these are, anytime you're talking about any validity related to a measure, they're all subsets of construct validity. So part of construct validity is content validity. It's subsumed under the larger idea of construct validity. So content validity is the extent to which items are relevant and representative of the construct for a particular assessment purpose. So the extent to which items are relevant and representative of the construct. So 2 pieces of that. One, did you ask enough questions or make enough observations? Right. So if you're thinking about the construct is depression, and you ask several questions about depressed mood. Do you feel blue? Do you feel sad? Do you feel low? Okay, those all may be good. You may get a good reliable thing, but your measurement may not have good content validity because the concept, the construct of depression, as we understand it according to the DSM-4 psychopathological conceptualization, is you have affective symptoms, mood symptoms. You've got these vegetative physical symptoms, and you've got cognitive symptoms, right? So you need to ask about mood, you need to ask about either weight gain or sleep loss, something in there, appetite. You need to ask about impaired concentration, feelings, thoughts of guilt, things like that. If you ask about all of that, then yeah, you might have good content validity. So are you asking broadly enough things that they're going to be representative of this large construct? Excuse me. The other thing is you need to make sure that you know exactly what it is you want to measure. Because sometimes you think, oh, I'm interested in depression, so I'm going to use this measure, make sure it has good content validity. And maybe you're not interested in depression as a large construct. Maybe you're interested in the cognitive aspect of depression, or the mood component of depression. That's fine. Just specify that in your paper that this is what I'm studying, depressed mood. So I'm measuring depressed mood. I'm not measuring depression. I'm measuring depressed mood. You're good to go. Okay, so we ask enough questions to cover the content, and they're all relevant to that construct. They're not off-the-wall things. Internal consistency. Excuse me. This is often talked about regarding reliability, but really is more of an indicator of validity. Right? So when you have multiple questions or observations that are supposed to tap the same construct, then they should be internally consistent. Right? If you're measuring anger and a participant is really angry, then she should look angry on all the questions. If there's one or two she doesn't look angry on, then you don't have much internal consistency. And again, as I said before, we use things like Cronbach's alpha, inter-atom correlations to help determine this, usually after the fact. So you've given the measure, and then you look at these data. But often, when you're choosing a measure, you'll look and see, okay, somebody else used it, and they reported the level of internal consistency was this. Right? So sometimes you'll choose your measure based on the published psychometric properties of that measure, how reliable and valid it was in the past. But you'll always report on, in your own study, how reliable it appeared to be with your particular sample as well. Okay, so content validity, internal consistency, and then convergent and discriminant validity. So these two things are looking at how your measure relates to other measures of other constructs. Right? So convergent validity says that your measure the results, the data should converge with other measures of the same construct. So I have a measure of depression. The people that score high on my measure, do they also score high on the Beck depression inventory or somebody else's measure of depression? If so, that's convergent validity. So these two measures of the same construct, the people's scores are correlated when they take both tests. That's convergent validity. If they don't, that's poor convergent validity. And then discriminant validity is that scores on the measure of a construct don't relate perfectly to measures of other constructs. Right? So scores on my measure of depression, and then I have somebody else's measure of anxiety. Okay, those scores might be somewhat correlated because those constructs are somewhat correlated, but if they're perfectly correlated, well, then maybe I'm not measuring depression. Maybe really I'm measuring anxiety. So I want to show that my measure of this construct is not perfectly correlated with measures of other constructs. That there's a discrimination between, oh yeah, I'm measuring this, not that, because they're not that similar. Okay, that would be discriminant validity. Now, coming back to the other side of the coin here, measurement validity related to external and ecological validity. And again, external validity is about being able to generalize the conclusions you draw at the end. And ecological validity is related to the degree to which your procedures and measures reflect the real world. Right? So, you know, a pen and paper measure of marital satisfaction versus behavioral observation of a couple at home. Right? Observing couples at home is going to have higher ecological validity because the data you're gathering is more like what you're trying to the construct. If your construct is, you know, marital interactions, that's more real world than having them answer questions on pencil and paper. Right? But things that have high ecological validity don't necessarily have high external validity, right? Because it may look like one aspect of the real world, but not all aspects or all context, right? It may not generalize beyond, you know, some particular couple's homes. Okay. Anyway, in terms of things we'll look at, criterion validity, which we look at predictive validity and concurrent validity are the two types of criterion validity. Criterion validity has implications for the relevance of the data generated by a measure. So it looks at how scores in the measure relate to observable outcomes. So similar to convergent, like convergent is, okay, you scored this on this measure of the construct, similar to that measure of the construct. Here, a measure of a construct has to relate to some measure, some outcome. So instead of, if I have a measure of depression, instead of getting another measure of depression, I find some outcome that's logically related to depression, maybe a number of days missed at work. Okay? And if my measure of depression is related to number of days missed at work, then that's criterion validity, right? My measure is related to this behavioral kind of outcome predictive thing. Excuse me. And if you look at it, and the difference between predictive and concurrent is quite simply, if I measure this construct now, and I'm trying to see if it relates to some behavior in the future, that's predictive validity. And then if I say, okay, I measure this now, this construct now, and I measure this outcome at the same time, then it's concurrent criterion validity, right? It's just a matter of time frame. Last thing under this part would be discriminative validity. So different than discriminant. Sounds very similar. Discriminative validity is related to criterion validity, right? This is where can the measure be used to reliably discriminate between groups who should differ on the construct being measured. So again, going back to depression, does my measure of depression, the people that have been diagnosed with major depressive disorder, so some psychologists or psychiatrists put the stamp, yep, they have this diagnosis. Do they score higher on my measure of depression than non-clinically depressed individuals? If so, then yeah, my measure discriminates between this group and that group, and I've got discriminative validity. Okay, time for a quick concept check, make sure things are making sense. If you're going to use some measure of anxiety, and you find that it's correlated with an established measure of anxiety, but it's not correlated with an established measure of aggression, What type of or types of validity have you established or maybe failed to establish? About convergent, divergent, discriminant, criterion, predictor, right? Convergent validity because it's converging with another measure of anxiety, and divergent validity because it's not correlating too highly with a measure of a different construct. Right? So both convergent, good convergent, and good divergent. If it was correlated with both types of measures, it would maybe have good convergent but poor divergent. Right? If your measure of anxiety correlated high with a measure of aggression, that's poor divergent validity. Okay. Okay, so we've talked about the importance of the reliability of measuring variables. Talked about some issues related to construct validity with measuring variables. Now we'll talk about the sensitivity of a measure. So what we're talking about when we talk about sensitivity, well, this is the degree to which your measure is able to detect differences among participants on the construct you're interested in. The degree to which your measure is able to detect differences among participants on the construct you're interested in. So if two people are only slightly different, so one's a little more depressed than the other, is your measure sensitive enough to give them different scores? Oh yeah, he's more depressed, she's less depressed. Or if they're just slightly different, to say, oh no, they're the same amount of depressed. If it says they're the same, then maybe that's not the best sensitivity. Just kind of a little side note here. For those of you who may have taken other classes of measurement, this is a little different than the concept of sensitivity related to sensitivity and specificity, right? Which are terms used for diagnostic tests related to number of false positives and false negatives, and that's what we're talking about. Sensitivity is the ability of a measure to detect the presence of something. So if it's there, it'll find it. It's a sensitive measure, and a specific measure is a measure where if it's not there, the disease, the pathology, whatever, that the measure will tell you, yeah, it's not there. That'll be accurate in telling you something's not there. So this is a little different than that idea of sensitivity, specificity, which is really about diagnosis or determination of the presence of some event or outcome. This is just more broadly, when measuring a construct, what shades of gray is it able to tease apart? Okay. So, how does this relate to reliability and validity? Well, you can't have sensitivity without good reliability and validity. Those are kind of prerequisites. The amount of reliability and validity your measure has will limit how sensitive it is. Right? So, again, if we're trying to say, okay, well, we want to make these fine distinctions between a little bit of this and a little bit more, well, we need a very valid measure that's accurately measuring that thing before we can even get down to can we make these fine-tuned distinctions. But the need for reliability and validity aren't the only things. You also need to be mindful of how the measure is designed and how the data will be collected. And this is because of the relationship between sensitivity and the variability present in scores. Right? So when you're deciding how to measure something, oftentimes you're deciding whether or not to measure a variable dichotomously or in a continuous fashion. Right? So dichotomous is kind of yes, no. Right? Or we could say more broadly categorical versus continuous. Categorical could be yes, no, or maybe. 1, 2, 3, 4, 5. A certain number of categories. Versus continuous is on a continuum. Right? So if you wanted to measure you wanted to show some political ad and then measure if it changed people's political orientation. And you have people, so you're kind of deep in the variable here is political orientation, and you give them the options. Okay, so are you Republican, Democrat, Independent, other? That would be categorical. Right? If you said, are you conservative or liberal? That would be dichotomous. Now, if you said, to what degree do you consider yourself to be conservative? 0, not at all, to 10, very much. Now we're looking at something on more of a continuous scale, right? And if we want to make it truly continuous, we can just anchor not at all on one end, completely on the other end, and have a line, and they draw a slash mark between the 0 and the 10 that indicates where they are. That way there really is an infinite number of places that slash mark could go, and it's a truly continuous measure. Now, why do we talk about this? Well, if you want to make these fine point distinctions, If you are using a dichotomous or even a categorical approach, a lot harder to make those fine-tuned distinctions than if you have a continuous measure, right? You're going to have less variability in your scores, right? There are less ways that people can be different. If it's, oh, I'm conservative or independent, you can be one of the two. That's not much variability. Versus if you have, conservative on one end and liberal on the other, and a bunch of choices in between, some numbers that correspond to degrees of conservativeness and liberalness. Okay, now there are more fine-tuned distinctions. Again, if you're using a number scale, 1 to 10, 1 to 7, 1 to 5, the more numbers you use, the more fine-tuned distinction you can make. The more sensitive potentially your measure will be. The flip side of that, the more numbers you make, you begin to get to the point, well, is there really a difference between, okay, somebody put a 7 and somebody put an 8, are those really different, or are they both just kind of high? Right? So there is some diminishing returns for some constructs. And it's going to depend on what construct you're looking at in terms of how you're going to want to measure it. But generally, closer to being continuous is better than being dichotomous, because the more variability you can get when measuring something, the more sensitivity you're going to potentially be able to pick up on. The other thing you have to think about are floor and ceiling effects. Right? So for your particular sample, how would people respond to this measure? Are people going to top out where, okay, there's, yeah, very much so, and if they could answer even more, they would have, but they can't because you didn't provide any higher range than completely agreeing. It would be a ceiling effect, obviously, or such that they give and they bottom out where they would score lower, but they got none right, and you can't get lower than 0. But really, some people were lower on that construct. Everybody got a 0, may not be the same. Some may be even worse on that construct. Right? That would be a floor effect. You can't see how poorly they would have done because the lowest they could have gotten was a 0 on that particular thing. And so again, that depends both on your measure, so how high and low can people potentially score, and on your sample. Who are you measuring, right? And if you're giving some measure of pop trivia, when you've got 5 questions, and you give it to a bunch of high school students, everybody might get them all right, and now you can't tell, okay, are there any differences between these kids in terms of how much pop trivia they know? I mean, there probably are some differences, but you can't figure it out because everybody aced it, right? There's a ceiling effect. Whereas you give those same 5 questions in maybe a nursing home, if it's recent pop trivia, you might find some differences. Right? Or you might find the other thing where nobody gets any right, you have a floor effect. So you got to think about what questions you're asking, how many options you're giving, and who you're giving them to. The other thing to think about, last thing about sensitivity, is the mutability, the changeability of what you're measuring. Right? You think about if the behavior you're measuring is liable to change, if it's mutable. Because if it's liable to change, given what you've chosen to do to people, so you manipulate some independent variable, I want to see, okay, can I make them more depressed, less depressed, more happy, less happy, more anxious, less anxious, whatever. That's important to think about if it's possible, if it's reasonable to assume that you could change something. Because some behavior characteristics are more volatile, more mutable than others. Right? You might be able to get people to move on some measures of attitudes about spirituality, right, by showing them certain things, telling them certain things. Excuse me. But you're probably not going to see changes in their core beliefs. Right? So if I say, oh, I want to see if I can change people's thoughts of spirituality, but when I measure it, I'm measuring kind of core belief stuff, I may not see any change. And so, oh no, it had no effect. If I measured more kind of peripheral stuff, that's where the change may show up. So think about if the thing you're measuring logically should change, and will it change in a way that you can detect it with the questions you're giving. Okay. So we've talked about reliability, validity, sensitivity. The last thing we'll talk about in terms of measuring variables, pretty quickly here, is the scale of measure you measure on. So hopefully this will be a review of stuff you've seen before. When you measure things on a nominal scale, this is where the values for the data are nominal. They're names, they're descriptive. Right? In So people's scores on a variable will differ in quality, but not quantity. So what's your favorite color? Red, blue, yellow, green. Okay, so red is different than yellow, but it's not more or less than yellow. Right? So you're measuring their favorite color on a nominal scale. Whereas if you measure things on a ordinal scale, now the outcomes or observations can be ordered along some continuum. So here's 5 colors. Put them in the order from your most favorite to least favorite. So now it's not just okay. Some people like red, some people like blue. We talk about okay, the number of people that have red as their first choice and they like red. The number of people that like red more than blue and more than yellow. Right? We talk about difference. Right? So ordinal gives us a little more information than nominal. Interval adds to that. Right? So for interval data, the variable is being measured where each data point occurs at equal intervals. Right? So we know how much more or less of a quality one outcome has. Right? Excuse me. So on a scale of 1 to 5, how much do you like red? Right? So I like it a 4. I like it a 2. I like it a 3. And this is different than ordinal because there's the supposition that the difference between a 4 and a 3 is the same as the difference between a 3 and a 2. Whereas for ordinal, there's no assumption of that because it could be, I'm ranking my colors: blue, green, red, yellow. But I love blue, I love green, and then red and yellow they're way down at the bottom. I don't like them at all. So the difference between 1 and 2 is really pretty close. But the difference between 2 and 3 is quite far. The assumption with interval data is that the intervals are equal. That's not the assumption for ordinal data. Last, we have ratio data. This is where you have equal intervals still and a true zero. That means that conceptually there could be a 0 on that scale would mean the absence of the trait. And things measured on a ratio scale are actually pretty rare. Temperature, when measured in Kelvin, is a ratio, not when measured in Celsius or Fahrenheit. Time is one of the other ones where you could have 0 time potentially. And the thing that you get with ratio is now you can say, okay, there's twice as much of this, 3 times as much as this. Right? So took somebody 2 minutes, took somebody else 4 minutes. Oh, the person who took 4 minutes, it took them twice as long. Whereas going back in the interval scale, okay, this group on average, on a scale of 1 to 5, they said a 2, and this group said a 4. The group that said a 4 didn't say twice as much. Right? And you can't say twice as much because that's twice as much is a ratio. And you can't have a ratio if you don't have a true 0. It's just a mathematic fact. Okay. So most of the data we work with occurs on an interval scale, which is good because most statistical procedures we use require that the data be at least on a ratio or interval scale. If you go down to an ordinal scale, you've got to use some different different statistical procedures, often non-parametric statistics. Or even if you're collecting data on a nominal scale, you're getting more limited in terms of the statistical procedures you can use, things like chi-square and not much else. Okay, before we talk about manipulating variables, just kind of want to fairly quickly run through a couple of different approaches to measurement. Not an exhaustive list here, but just some of the broad categories of the most common types of approaches to measurement you might see in articles or think about using yourself. So probably the most common would be self-report and other report, where we're asking people to report on their behavior, their thoughts, their feelings. Right? And we do this in typically either interview settings or with surveys and questionnaires. What's the difference between a survey and a questionnaire? One begins with an S, the other begins with a Q. Okay. One thing about the difference between interviews and surveys and questionnaires: with interviews, social desirability may be a bigger factor, right? Because you can only have less anonymity, and there's somebody right there looking at you. You don't want to admit to maybe some of your darker truths, whereas you'll be freer telling those things in more anonymous surveys and questionnaires. Interviews also allow you to sometimes probe further and kind of get clarification. People say something, well, what do you mean by that? And you can't do that with surveys and questionnaires. You can't follow up with, well, why did you say that here, but that's here? That's inconsistent. You can do that in interviews. On the flip side, interviews, because you can do that, often have more subjectivity, because you won't necessarily ask everybody the exact same questions, especially if you're not using a fully structured interview. Using a semi-structured or an unstructured interview, you've got some leeway in there, which can give room for bias. Whereas surveys and questionnaires is much easier to standardize your approach to gathering data. Everybody gets asked the same questions in the same order. They have the same amount of time to fill them out. You can control all of that. Do you get accurate information from self-report or other report? Maybe, sometimes. Sometimes people are unable to know the answer to a question, right? Just because they don't have that insight, right? Either maybe about themselves, if you're asking other report about somebody else, they just don't know. Sometimes they can't remember if you're asking about things in the past. And again, the further in the past you ask about things, the less confident we are about the truth of what happened. I mean, you may be confident that, yeah, this is what they remember, this is their story now, which again may be important for your study. You know, if you do kind of a narrative therapy type thing, well, I want to know how people talk about their childhoods. Okay, doesn't matter if it's true, but that's their current understanding of their memory. But if you're interested in actually what happened when they were kids, the further back you go in time, the less reliable you're going to get. Less reliable the data are going to be. Okay. Sometimes they just don't know the answer. Sometimes they may know but don't want to tell you. Right? So they may lie, may not be honest. Okay. One thing important to note about other reports, so if we're gathering data, say on a kid, and we ask the teacher about the kid's behavior, we ask mom, we ask dad, and we get 3 different pictures of this kid's behavior. Does that mean that one or 2 or 3 of the people are lying? Maybe, maybe not. It could be that the kid displays different sets of behavior in different settings with different people. It could be that the different people have different expectations for the child's behavior, therefore they interpret a child's behavior differently. Or it could be a combination of all of those. So you've got some interesting things to figure out if you're going to use multiple reporters, and what do you do whenever things aren't consistent? How somebody describes themselves when it's not consistent with how their partner or their parent or their child describes them. What does that mean? And you need to be thinking about that before you get the data. Have a plan for what you're going to do with discrepancies. Okay. Physiological measures, right? So things like blood pressure, heart rate, EEG, MRI, fMRI. Good thing about these, hard to fake. Not impossible to fake. Right? You can beat a lie detector test, I've heard. So you can control your physiology to some extent. Right? There is some top-down control, but it's hard. It's harder to fake these things than it is to lie on a questionnaire. So that's good. On the flip side, there's some ambiguity regarding the results. Right? There are many physical phenomena, physiological measures that are related to multiple psychological constructs. Right? So if somebody's sweating, could be they're anxious because they're lying. Could be they're anxious because you've got electrodes hooked up to them. Could be that they're angry because they're sitting here having to answer questions. Could be they have generalized anxiety disorder, right? So a lot of physiological measures, indicators, are fairly non-specific, and they could mean more than one thing, which leads them to potentially be misinterpreted, which is why you often need, if you're going to use physiological measures, you need other measures coming in that are different, that then you can triangulate, right? So, okay, this physiological measure of stress, we have this self-report of stress, and we have this other measure of stress, and they all said the person was stressed. Okay, perfect. Right? So using multi-method, multi-trait assessment is always the gold standard. Okay. Beyond that, third type of approach to measurement would be direct observation. Right, you're just going to go and we don't know if the kid's aggressive. We're not going to ask the parents. We're not going to ask the teacher. We're going to go watch the kid on the playground. To do this well, it needs to be systematic. So if you're If you're a clinician, you might just go watch a kid to get an impression. If you're going to be empirical about it, if you're going to be scientific about it, you have to have a plan going in. Okay, I'm going to go watch a kid, and I'm going to look for these behaviors, right? Or these are all potential behaviors I could see. If this happens, it'll mean this. If this happens, it'll mean this. Or every 5 minutes, I'm going to see if they're doing this or if they're not doing this. Right? So you have to have a plan going in that's systematic. Otherwise, it's very likely to be biased by your own expectations. The other thing that's important to remember for direct observation is make sure you get an appropriate sample of the population of behaviors. Right? So if there's a kid that is having problems with aggression, and you say, oh, well, I watched the kid in class and she was fine, he was fine. Okay, maybe, but maybe it's not in class where they have the problem. Maybe it's on the schoolyard, or maybe it's at home. So you've got to get a big enough sample of the behaviors to represent the population of behaviors that you're truly interested in. Okay, so now on to moving from measuring variables to manipulating variables. So when it comes to manipulating variables in a study, what kind of choices, what kind of events can impact the conclusions we can draw? One would be the type of manipulation that you, so we'll talk about different types in a minute. The reliability of the manipulation you choose, so that should sound familiar, right? And the validity of the manipulation you choose. So very similar. All the things that we talked about, or many of the things we talked about in terms of measuring variables and construct and validity, will also apply to the manipulation of variables. Okay, in terms of different types of manipulation, let's talk about two basic types. One being the most frequently used one, which is the instructional manipulation, right? That's where you're giving oral or written instructions that differ across groups or across levels of the independent variable. That might misunderstand directions, and they might be influenced by demand characteristics, right? We talked about before in terms of there may be demand characteristics present in your measure. There may also be demand characteristics present in your manipulation, right? It's because when you're getting instructions, sometimes it makes it easier to figure out what the study is about. Right? You're being told, okay, when you look at these pictures, judge how appealing or unappealing they are. Okay, and you're getting these different pictures of older people and younger people, and it's pretty clear that there's two groups of pictures being presented. You say, oh, this is about, do I find older people or younger people more appealing to look at, right? So that's one kind of drawback to an instructional manipulation. But again, most commonly used because it's a lot easier to use. The other kind being environmental manipulation, which quite frequently makes use of confederates. So an environmental manipulation is when you're simply doing different things to people that are in different levels of the independent variable, or in different groups. Right? So this is kind of where you can get really creative and do some fun stuff with behavioral science, right? You could go in an elevator and stand facing the rear, right? And you see who turns around, and you do it in a couple of groups wearing an NFL jersey, right? The jersey of the whatever town you're in, and then you go do it with another couple of groups of people in elevators, just random strangers wearing a Brooks Brothers suit. You say, okay, do people more likely to turn around in one condition than the other? When will this kind of awkward behavior have some sort of conforming influence, or people say, oh, maybe I should turn backwards. Right? So you can do neat stuff like that. But on the flip side, it's trickier to standardize something like this, right there, because there are all kinds of different things that can be different when you're doing stuff out in the world and you're manipulating people's experiences rather than simply manipulating some words on a page. Right? It's pretty easy to standardize. Okay, these words are going to be different than these words only this way. Right? They'll be the same font, the same color paper, all the things we can control. Out in the real world, it's harder to control other things. Like in the elevator one, how many people were in the elevator when you got in with the suit versus the other one? Was the elevator going up or was it going down? All these other kind of variables, more difficult to control. In terms of confederates, right? So that's one type of environmental manipulation. I think merits more discussion. So confederates are people who are involved in the study, but pretending to be participants. Okay, so people who are involved in the study, but they're pretending to be participants. So they're confederates of the experimenters. Right? I did this when I was an undergrad. We're doing a project looking at male answer syndrome, the tendency of men to make up answers to questions that when they didn't know the answer to. So usually it was things where either it's really unlikely people knew the answer, or there was no known answer. So, okay, will they say something, right? And so I played a Confederate, where in some conditions I would hazard a guess, so I would exhibit manager syndrome, seeing if that would kind of prime the pump to get the other guy who's in this kind of discussion group with me to also do it. And then in other groups, I said, oh, I don't know, right, to see if that would damper somebody's likelihood of hazarding an explanation. And again, tough to standardize, right? You got to have a script that you're going to try to stick to, but hard to stick to a script exactly if the other people in the room, the participants, ask you other questions or interact with you in a way that can't be accounted for by your script. Right? The other thing, you're misleading people, which we already talked about, which leads to over time an erosion of the public's trust in behavioral scientists, and sometimes that erosion of trust might even extend to mental health professionals. Although those people are always trying to trick us, right? So we don't want to do too much of that. Okay, in terms of how to increase reliability in manipulating variables, I mean, what you're trying to do to increase reliability is reducing error, right? And how do you reduce error? Well, you standardize the manipulation, right? Because overall, you want to be confident that your approach to measuring some variable accurately and faithfully assesses differences in that variable. And you likewise want to be confident that what you do to or with participants to manipulate the IV, the independent variable, accurately and faithfully represents different levels of that variable. Right? So if you want to look at the effect of depressed mood on memory, you might use some technique to create a negative mood in people, show them different movies or different music. It's impossible to be 100% sure that what you do will cause the change in mood you're interested in. So there's some room for error, and that's why we talk about these ways to reduce error, including standardizing the manipulation. Right? So having standardizing the manipulation means you have very clear rules about what will happen to participants, and you make sure they're followed. Right? As much as possible, you want participants at different levels of the IV, in different groups, different conditions, to have identical experiences, with the exception of the independent variable. That's the only thing that should be different. Right? And you want the independent variable to be, the way it's being manipulated, to be true to the construct. Right? So if you're doing a study looking at, is this therapy better than this other therapy? So you're going to train therapists up on how to do each therapy. Probably have to use a manual. So everybody's going to be doing the same thing. Day 1 is this. Day 2 is this. Day 3 is this. It's a 6-week manual. And each week you have certain things you have to talk about. And you train them on that, which is part of standardizing. The other part is spot checking to make sure they do it. Right. So you randomly select sessions that are videotaped or audio taped, or you live observe and say, okay, on session 6 they're supposed to be doing this, this, and this. Did they? And you don't have to watch every session, but you randomly sample from the sessions, and you can calculate reliability estimates to see, okay, how faithful were they in terms of their adherence to the treatment, right? To the fidelity of the manipulation of the independent variable. Right? So that's another part of the standardization of manipulation. Another important thing we already talked about a little bit was having the experimenter be blind to the condition that participants are in. Right? So experimental bias can lead the person conducting the experiment to subtly treat one group different than the other in ways that might support their hypothesis. Right? So you get around this by not letting the people running the experiments know who is in what condition. So the experimenters who design the study will often hire people, or just get students who you don't have to hire. You just tell them to do stuff, which is a nice source of free labor. You get students, or sometimes you have paid researchers who you'll employ to collect the data, right? So they're going to be running the study, and they don't know who's in what group. They may not even know what the study's about. All they know is, okay, I'm supposed to go in this room, I read this statement, and then people are going to write some things down. I'm supposed to pick it up after 20 minutes, right? So they don't know what's going on. They're blind to condition, and that can help increase reliability. Another approach is the use of placebo groups, right? And this is that classic thing where we see, okay, does this thing have an effect? So we give the thing to one group, and then we give nothing to the other group. Or we give them a placebo, so something that is inert, it has no effect. And the traditional example is with a drug study, right, where you're giving somebody a pill that has some amount of caffeine in it, maybe, or antidepressants or whatever, and the other group is getting a pill that just has a little bit of sugar in it. There's no no psychoactive substance, that pill shouldn't cause any changes in behavior. And people don't know which pill they get, right? Maybe, right? If you're in a study, you're in a drug study, and you know, okay, I could be in the drug group, I could be in the placebo group. You're taking a pill once a week, and you notice, oh man, my stomach feels funny, and my skin's kind of blotchy. Oh, I think I must be in the pill group, right? Because the pill is going to have some side effects. And placebos will have side effects too, but not as many as the pill, right? So people in the pill group often kind of figure out that they're in the pill group, and so that leads to, again, to demand characteristics, where they're going to act a certain way because they know they should be getting better. Same thing in the placebo group. If people aren't having side effects, they may figure out that they're getting the sugar pill. So they go, oh no, I'm not getting better at all, even if they were, because they don't expect themselves to, because they've now suspected or realized that they got the placebo. Right? So it can be a problem in some drug studies. Even more problematic for clinical studies looking at difference in therapeutic approaches, for a couple of reasons. One, if you had a study where one group gets therapy and the other gets non-therapy, so they're meeting with somebody weekly but not getting any therapy, they're just talking about stuff, right? Sometimes people talk about that, oh, it's going to be general factors. Well, guess what? When you do those studies, people that just go and get to talk about stuff, they get better, right? Because going and talking about stuff, even if you're not using sort of manualized treatment, that can often be therapeutic, especially if the person you're talking to is a trained therapist, right? It's hard to get a therapist not to be a therapeutic presence, right? If you have them going and talking to a plumber, it may be a different study, but then you got ethical concerns about that, obviously. So it can be hard to get a true placebo. So more frequently what's done is either treatment versus wait list, right? So, okay, everybody's going to get treatment, but half the people are randomly assigned to start now, half the people are randomly assigned to start 2 weeks later. And then you can kind of see if the groups start to get better, but one group gets better 2 weeks before the other group, then you think, oh, that's because of the therapy, right? And that's a more ethical approach than giving people something that you think, oh, you're really depressed, but we're going to give you this treatment we don't think has any effect. And there's a problem. We'll have to kill themselves, right? So ethical concerns there. And the other thing, even if you do a wait list study, if you have severe depression, somebody says, oh, would you like to be in this study where we give you free treatment? Yeah, sounds great. But you're going to be randomly assigned to either start now or wait 2 weeks. It's really depressed. You might say, nah, sorry, I need to see somebody now. I can't take the chance that I'll be in the wait list group. Right? So you may end up getting kind of a biased sample where it'll be biased such that it won't fully represent all the people who are depressed. It'll maybe more likely be people who are mildly to moderately depressed. So the people that are more severe and want treatment now may not be in your sample. And people who are also just kind of highly motivated to seek treatment urgently, not going to be in your sample. So your sample may not be fully representative of all depressed people, so that may lead to problems with external validity. Okay, so kind of one step kind of above a wait list. So a wait list is better than this kind of no therapy, but even better than that is just comparing, okay, how does this therapy do compared to this other known therapy, right? And typically when you do that, you do pre-post on both. That way you're not just looking, okay, was this therapy better, but okay, people improved in this one that we know they're supposed to improve, and yeah, we confirm, we replicated, they improved that same amount. In the other study, they also improved, and then statistically, in addition to that, we can say, okay, what about, did they do better in this therapy? Which is often a good thing to say, okay, there's this 10-session therapy that's been shown to work. We just showed that this 8-session therapy works just as well or better if it's 2 weeks shorter. Okay, now insurance companies are going to want to pay for your therapy and not the longer one. Excuse me. Okay, in terms of the validity of the manipulation, obviously, just like with measuring, to have validity, got to have reliability, right? So if you don't have, if you aren't reliably manipulating your variable, so if it isn't standardized where you're always, manipulating it the same way across participants, right? Then you can't have validity. So that reliability is a prereq. Beyond that, one thing that may be a concern is the strength of the manipulation, right? So we're trying to maybe scare people, right? We're looking at the effect of this fearful stimuli on heart rate. We want to see how much it goes up and how quickly it takes to come down if we've taught them some self-soothing skills, right? So they think, oh yeah, this will be totally scary. They'll be in this room and we'll be playing soft music, and then all of a sudden we'll play the theme to Jaws, right? Do 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 do. That thing. Now, if they're from my generation or older, it might work. Younger than me, you want to be like, oh gee, what's that weird sound? Because they didn't see Jaws in a theater, maybe at all, and so it won't cause fear. So you want to make sure that the thing you think you're playing. So I think I'm showing something scary. Well, are you really showing something scary? And a good thing to do is, before you run your study, you run a pilot study. Right? A pilot study, you get a small number of people. You don't need a big representative sample. Maybe a random sample. You get a couple of your friends, and you test out a couple of things on them. And one of the things you often test out is doing a manipulation check. Now, in a manipulation check, if you have an independent variable, dependent variable, you're not looking at the effects of the IV on the DV, right? So maybe in that study I'm looking, okay, in one group people are going to be taught relaxation, another group they're not. So the independent variable is relaxation. So when I do a manipulation check, I may not be looking at that per se. I may be looking, okay, I'm going to try to scare these people, so I'm going to show them whatever my scary stimulus is, and I'm going to say, okay, how scared are you? I just see, okay, do I really get some fear? I may measure heart rate even, and say, okay, do I get a noticeable bump on this variable? Something, is there variability that I can go and find? The other thing you could do is, again, if you're teaching people these skills, you do a manipulation check where you don't show them anything scary. You teach one group of skills, you teach another, you don't teach the other group of skills, and then you give them a quiz to say, okay, do you know these skills? To say, okay, did I really teach them this thing? Did my manipulation work? Okay. Excuse me. Okay. Another thing to think about is we think about your choice of independent variable and how to operationally define it. Always go back and look at previous research, right? It's often useful to use a manipulation that has already been studied in the past, right? Because we'll have some data on how people react to it. We'll kind of know, okay, this big of effect was found when they showed this movie, when they presented these words, and maybe you're doing a study that's different, but you could use that same manipulation. Because now you have some idea about the psychometric properties of that manipulation and if it actually was effective in causing some effect in some other study. So that can often be helpful. Finally, looking at external validity, we want to know how representative, if we're presenting a bunch of stimuli, right, for an independent variable. We show you these pictures versus these other pictures, right? So are the pictures we showed you representative of all the stimuli, of a population of stimuli that represent that construct, right? So you want to say, well, how do people respond whenever they think they're talking to someone who's attractive or someone who's unattractive? So the pictures I show you of attractive people, how representative are they of all attractive people? Same thing for unattractive. Like was there diversity in those people other than attractiveness? So they're all attractive, but some were older, some were younger, some were men, some were women, some were of this ethnicity or that ethnicity. Did I have all this fully representativeness of the stimuli, or not? Did I have just one picture, a couple of pictures, and they were all pretty much the same? And same thing for the unattractive. They're all unattractive, but they're all similar otherwise. If so, I may have poor external validity of my independent variable, which isn't necessarily the end of the world, right? Because you're showing, okay, yeah, there is this effect of attractiveness versus unattractiveness for these types of pictures. Well, is it also true if I show pictures of older adults who are highly attractive and maybe unattractive? Maybe the difference is, okay, the pictures are similar to or dissimilar to the participants, right? Maybe that's the variable you want to look at. But you can always do that in the next study, right? You don't have to set up all of external validity in a single study. That's usually a fool's errand. Okay, quick concept check, make sure things are making sense. If you're interested in the effects of sleep deprivation on concentration, you might first subject a group of participants to different levels of sleep deprivation and measure how tired they are. This would mean you did a what? manipulation check, right? Perfect. I knew you knew it. Okay, heading toward the end here. Sum it up. The choices you make of how to measure your variables, your dependent variables, your criterion, or predictor variables, and your choices of how to manipulate a dependent variable affect the conclusions you can draw. They affect constructability immediately, and then that effect on constructability then has an effect on sometimes internal validity, and sometimes external validity, sometimes both. Okay. Another thing to keep in mind here is there are all kinds of opportunities for methodological creativity, right? So again, I said, it's often good to find stuff that's already been done and use it again. There's also something to be said for coming up with unique ways to manipulate and measure variables, because maybe the way a variable has been measured in the past hasn't been quite perfect. Maybe there's inconsistent findings. We say, oh, sometimes the therapy works, sometimes it doesn't. Maybe it has to do with how they were measuring the outcome, in terms of getting better, right? So maybe you've got some new way to measure improvement after therapy, right? So opportunities for methodological creativity abound. Okay, in terms of your study, your proposal study for class, again, I encourage you to at least look at existing measures because you can, in your paper, you can report the psychometric properties. Previously it's been shown to have good reliability and validity with coefficient alpha equal to this. It was correlated with this other measure, R equals 0.85, whatever. You can report that stuff. If you make your own measure, one thing you've got to say, the psychometric properties are unknown. And the second thing is you've got to describe it in much more detail, right? Because it's an existing measure, it's public access. Anybody can go out and find it. If something you created, you've got to include it in an appendix within your paper, and you've got to provide a richer description of everything in that measure and how it was created in the first time you use it. Where do you find information on existing studies? The Mental Measurements Yearbook with tests and print is one of the databases on the library's webpage. Right? Go under M, there it'll be, and you can type in different, depression, anxiety, PTSD, whatever, and search for existing measures. And what the things that'll be in this database are reviews of the measures. People talking about, oh, it was good at this, it was poor at this, it has good internal validity, good reliability, whatever. So all that information will be in the articles you can find in that database. The other thing to do is to read the method section of other articles, right? So other articles that you're looking at for your introduction obviously are looking at similar questions, hopefully. So look at, well, how did they manipulate the variable? How did they measure it? Did it seem to work out okay? Did it seem to be an appropriate manipulation or appropriate measure? If so, you can use it again. If it's something that they created, then you want to cite them. If they use the BDI2, you don't have to say, oh, we're going to use BDI2 just like somebody else did, because that's a commonly used instrument. But if they created an instrument for their study, then you definitely want to cite them and say the instrument created for such and such study, and you can even alter it. An altered version of the instrument created by such and such, where we eliminated questions 7 and 8, whatever you're going to do. But you have to describe that if you're going to make changes. Finally, before you go looking for measures, make sure you've clarified your constructs first. Make sure you have a good idea of, okay, I think I'm looking at the effect of this on this, or the relationship between this on this. Do you really know what those things are? Like I'm looking at the effect of cheating on infidelity. Okay, well, what about cheating? 'Cause that's kind of a broad thing. Sexual infidelity, emotional infidelity, online infidelity. What part of that am I really interested in? In terms of the effect of infidelity on relationship satisfaction or on divorce. Okay, what part of that am I interested in? And think about that. Spend time thinking about that and sussing out, okay, theoretically I want to know this part. Then go look for your measure. Okay, I know that was a long one, sorry, but that's all for now. Take care.